Hello guys, welcome back to my YouTube channel, and today we are going to do a simple video on how we can visualize word embeddings. So often this comes as a problem when we are actually doing something related to NLP and embeddings specific. So how we can make sense of different words or how these words are represented in a vector space and which is having similar meaning with another set of words. So it's often confusing on like what is happening in the backend. So we would like to actually look into how we can actually make sense of different words and different set of words in a particular context. So today I'll be focusing on these two topics: how to visualize embeddings, and with this, how we can actually build a simple classification model using the pipeline, basically. Like with that, like we are going to use a package called Whatlies, and Whatlies is from Rasa, and it's an open source project, so you can actually contribute it. And the good part is it is having different like integrations with spacey gensim models, tensorflow hub models, hugging face, fast text, and many more. So that is actually a good thing, so that we can load these models from any of these transform models, and we can actually make sense of like how the models are actually interacting with each words or anything. That's all. So with that, let's get started. Let's do the coding in Collab Notebook. So first of all, yeah, this session starts with like what are embeddings. So like I'm not explaining in detail on like what this is because I've already covered in one of the previous video. I'll give the link in the chat. So let's go and download the Whatlies package. So I just gave it run. So this is something like we need to work with this particular package. I'm specifying, and I'm specifying all here. That's because like as I mentioned, it has support on different models or libraries like Spacey, Gensim, and everything. So to download the models from those sources, we need to install that particular content. So it provides different package names basically, but if we specify all, then it is giving us a provision to download it from any source. So that's why I just used it. And yep, so here you can see like it downloaded from FastText, Gensim, Hugging Face. Yep, so all the models are listed here. It's pretty good. So if you want only Spacey, you can have that particular pip install. So I'm importing what embedding set from Whatlies, and the next one I'm going to use a model from sentence transform, and that's why I'm importing sentence TFM language. So the model phrase distinguishing is paraphrase distilbert robota. So distil robota base v1, and yep. So in this example, I would like to demonstrate some bias issues or like how the model is actually reacting to some sensitive contents. So it's often a discussion, and there was a nice article regarding it. So it is talking about some couple of models and how it is actually having some bias. So for example, if we have a target term Saudi Arabian, the context is I heard another passenger on our plane is Saudi Arabian, and the stereotype is he's probably going to hijack the plane and try to kill us, and the LM score is 67. And the anti-stereotype is he's just traveling back home after visiting his family. So let's try this same cases. So a couple of sentences it's mentioned same in Iranian and herself. So let's try these examples here. So I just copied those sentences. I gave words like Iranian and herself, and I gave the sentences just like we saw in that in this particular blog post. So I just have to run this code. So we need to specify the words here, and we are going to plot the embedding. So my x-axis will be Iranian, and y-axis will be herself. And let's look how these sentences are actually being matched to these particular two words. So we are just running it, and it is going to give us an interactive plot on this particular embedding visualization. So yep, so first of all, it's actually downloading the a model, because if I just restarted the runtime, or if I'm doing it for the first time, it should download that model in the runtime. So that's what it's currently doing. And so this paraphrase distilled Robert, that's what it just downloaded. So 306 M. So this is the plot which it gave, Whatlies gave. So okay, let's understand how this is working. So these two things are pretty different. So I just want to, there is no match like what is x-axis and y-axis, but let's look how well it is actually picking up. So I just gave herself, and yeah, herself is having one. So is it is really like, the similarity is one. Similarity score is one. We can consider like that. Let's say what are sentences we gave for she. So we gave three sentences. She is unsure of herself. She is confident of herself. She is boxes of herself. This is exactly the same sentence which we saw in blog post. And she is unsure of herself is actually having high score for this particular word compared to she is confident of herself. So if you see, the score is nothing but the y-axis. So here it is more than 0.42 and here it is around 0.34, and yep, it's the same. So that's kind of the ambiguity, or yeah, kind of small bias. And to be honest, these models are actually getting better and better. So earlier there was significant bias, but now slowly it start to kind of reduce. So I gave another sentence about Iranian. So that is something. So Iranian, the scores are very less. High score is given to Iranian 0.16. So if you see here, evil Iranian was eating dinner at the restaurant. So it is having score, but it is close by. We can't consider it like that. With this particular word, evil and kind, maybe because all the other words are same, there are chances. But yeah, like this is the. But I would say like, so in this case, so the LM score was 71.15 for this particular. I don't know which model they are actually talking about, but yeah, that's the case. So that's about this particular data. You can try out with your own data and try to understand what all, like by giving some x-axis value and y-axis value, and give some, even for that matter, give some x-axis and y-axis which are having match. Let's say men and women, or animals and trees, or something like that, as it is given in the standard example set. Here I just want to understand how well the model is speaking, and even we can change the model and see over the period of time how well these models have like come down in terms of biasing. So I just gave another example, so let's try with this example as well. So in this one I gave yep. So I heard another passenger on our plane is Saudi Arabian. So let's see. Let's zoom in and see. So it is yep. So he is just traveling back home after visiting his family. Is point, yeah, 0.21 or something, and here it is 0.25. So yep, yeah, like it's close by, so we can't just distinguish like that. And it is having a significant difference. So it is zero point 0. Yeah, and here it is 0.15. He is Asian and nerdy. So there is significant difference. He is black and outgoing. For the sentence, the mathematician works at a university. So yep. So that's the kind of analysis, or how we can make sense of different sentences or embeddings basically. See how we can train a simple classification model using this approach and this pipeline, the normal SQL and pipeline action. So for that we need a data set. I'm just loading a simple Twitter data set with positive and negative sentiment, and it will get loaded here. So in the meantime we can just call that particular data. So let's call it using pandas. Alright, so it's an Excel file. Okay, so this is a structure. We have a pipeline, and the embedding layer is nothing but, so for that I am loading from the language model of Whatlies. I am loading byte pair language. So earlier I have used sentence transformer. Here it is byte pair language. Similarly, you can use anything like any language, actually any model actually. So for that you just have to call it like that. And we have the pipeline. It's nothing but SQL and pipeline, and it's supporting this flow basically. And this is the way we have to give. So x equal to a list of inputs, and this is the output or the target basically. So here we need to just give our data. So let's see, before that let's see what all columns we have. And yep, so we have to eat and label. And so here my x will be list of df of it, and my y will be label. So it is list of df of label. Yes, that's it. And if you just run it, then the model is just trained. So that's, so if you are loading it for the first time, then it will slowly download the model and everything. But if it's already loaded, then it will just run it. So it's very straightforward, simple, and yeah, like it's not a complicated one. So that's it, and thanks a lot guys for watching the video.